Welcome back to the Arctic Turtle series. This is episode 6, the final one of the series. And if you've not seen the others, please do a search for Arctic Turtle series and you'll definitely find them. This episode is about the climate and permafrost of the Iqaluit area. And as a physical geographer, I hope to clear up some misconceptions about climate change, and permafrost. What is climate? Well, it is essentially the weather of a location averaged over 30 years. For example, the average temperature of a site may be 12.4 Celsius over a period of, let's say, 1950 to 1980, and maybe comes out to 12.3 Celsius over the next 30-year period. This is then actually considered climate change as the average temperature dropped by 0.1 Celsius. Of course, we would expect some variation over such a period due to variations in solar output, wind patterns, tilt and orbit of the Earth, and so forth. However, the definition of climate is actually a very poor one. The 30 years is an arbitrary number, and the climate values would look different if it was based on 50 years or 100 years. The Köppen climate classification of Iqaluit is the polar tundra climate. Incidentally, the Köppen map was originally drawn in 1914, and the climate classification boundaries remain virtually identical today. Iqaluit has long winters and no month that averages above 10 Celsius. It is often said that trees do not grow here because of permafrost. This is incorrect. Trees need at least 1 month per year with an average temperature of 10 Celsius or more, while permafrost requires a mean annual temperature of below 0 Celsius. Many places have both trees and permafrost. In Nunavut, Northwest Territories, Siberia, and Yukon Territory. In Alaska, there are examples of drunken forest where trees have been affected by permafrost and lean in different directions. Trees do not grow on Baffin Island simply because there is no growing season for trees or higher plants in summer. Permafrost is defined as ground or subsurface that remains frozen for a minimum of 2 consecutive years. It makes no reference to the type of material, which could range from sand, clay, or solid bedrock. The top 1.5 to 2 meters of ground thaws each summer, and this is called the active layer. Below the active layer exists permafrost, which extends approximately 100 meters down in Iqaluit. The top of permafrost is nearly impermeable, which means it tends to collect water, which can then freeze into ice lenses. The Iqaluit area is very rocky and therefore lacks typical permafrost geomorphology like ice wedges and polygons. However, we can find other evidence of permafrost. Here we see solifluction lobes in Sylvia Grinnell Territorial Park. During frost cycles, the ground heaves and then is later pulled forward by gravity when thawed. Surface ponding is other evidence of permafrost. Water like this can suddenly disappear if the ground thaws and active layer pulls out the stopper. The satellite picture here appears to show hummocky ground just east of Apex, caused by road construction, although I was not able to visit the site to verify this. A CBC documentary incorrectly claims that the leaning of old buildings in Dawson City, Yukon is due to climate change. But in fact, it is the result of building incorrectly on permafrost. Building on permafrost is challenging. Homes and other buildings can affect the top of permafrost by expelling heat downward. Since the top of permafrost is often rich in ice, ice lenses can melt and weaken the footing of a building. If, on the other hand, a building is built on solid rock, this is not much of a problem. In Nunavut, however, all buildings must be built on stilts for this reason. The airport building in Iqaluit offers a unique challenge due to its large footprint or floor area. So it has a system of pipes containing fluid, which carries heat to cooling columns, which are then air-cooled. Permafrost is a relic of the last ice age. And while in southern Canada glaciation ended about 12,000 years ago, the Iqaluit area was still covered in ice around 7,000 years ago, a difference of some 5,000 years. Baffin Island has two large ice caps and many other glaciers, and therefore still partially in a glacial period. We should enjoy this interlude because scientists are fairly certain that the next major glaciation will start in about 60,000 years.